Right. So, in this class what I am going to do is first show you the broad plan once again what this is about. Just a quick recap. You can all read this, maybe a little bigger. Yeah. As you can see, normal flow that we have been offering now is to start like this, the big picture about chemical industry globally, in Indian chemical industry and so on, and then drift down to getting down to jobs into that. This year we made a change because this is to some extent a macro picture. It is more or less what you can read in newspapers, books if you have it. So, it has definitely a relevance, that is why it was put there, but this time we are trying to experimentate straight away plunging into this part. And later on Professor Nagarajan will dwell in these two, try to at that time take notes from whatever we are discussing in this class and tomorrow's class and see how far do you think it is relevant to the context that we are talking about, because jobs are relevant to the context in which we are working on. So, this is a small change, so that I thought I will explain to you, that is all I will do with this, and then I will straight away get into today's and to some extent tomorrow will be on description of what it is to work in chemical industries as an engineer. And of course, when we say working in industry, we have to talk about a career, which means the time that you initially join as a young person, then you grow either in the same company or by switching companies or sometime even switching industries. So, what we are going to say would be a kind of picture across time, across domains. And in more detail tomorrow we will get into the brass tacks of a job description and then get into what it takes to do the job very well. So, that is the picture, right. Today will be a kind of a fluffy overall, and tomorrow we will pick specifically that jobs which is of relevance to us as excuse me, entry level jobs. I am sure all of us are interested in the job of CEO, but that comes probably a little later. So, we will stick to this class, everything will be included, next class will be specifically entry level jobs. So, this is the title of this. Now, this is my favorite slide, because in this slide what I am trying to convey is to at least remove some of the misconceptions that is very popular today. You go to any popular place, there is a lot of hype being built about in any subject, it does not have to be subject dependent, anything is hyped up. So, this is my favorite slide because I wanted to bring down the hype a little bit and also be factual. You can go through that. It starts with the first question and then my view of, which is I think is mostly reflective of what is reality life is. This is what I said. You can take any one of them and think about it. Take one of them for instance. First one, there is a tendency these days people are looking for an exciting job, right. This word exciting is often used. To some extent I think we should be worried about this, because what is exciting to one person may not be exciting to the other person, and jobs cannot be like that, I mean by and large. Secondly, human nature is excitements do not last for long. Have you been ever excited 24/7 for one day? So, therefore, I feel that on the other view, without of course demeaning that the jobs have to have some excitement, that is given. Therefore, I want to give the counter view to say certainly jobs have to be of some use to the person who is doing it of course, and also to somebody else at large in the society, right. So, that is a reflection. You can pick and choose any one of them, but this is a very important slide, keep it in this. I am going to put this in Moodle, so you will get copies of all this, or if something strikes you, you can make a note and then come back to me and ask me. So, I will not dwell into this detail. The point is, look at reality as it is, try to build a little bit better than what it is, but let us not get trapped with hypes. The second quote, it starts by, Professor M.S. Anand, he is an emeritus professor in our department. He taught me fluid mechanics, and our relationship is for the last about 50 years. So, he made a very nice one which he said, he talked about engineers in general, because he was not restricting himself to chemical engineers. So, he was talking about engineers themselves, and I rather liked it. He says, looking at it, engineers in companies, what they do, they make stuff that God forgot to make. This made a huge impact on me. So, I am copying it. Think of that. Second way of visualizing is, think of a typical day. From you wake up in the morning, you do your routines till the time you go to bed. You would be using a number of things. Pick a few of them and look at that. Almost a large percentage of them will involve some chemical process or other, if you really spend few minutes thinking about that. Up to that, I think we are okay. For instance, can someone tell me what could be the chemical or process involved in this? Yeah, pigment, because it is color, okay. Molding, the way it is made, it writes, therefore there is an ink, there is a formulation, and it has to sort of flow, but not flow, all that. So, almost all products that you use in everyday life, sometimes the connection is not very easy. I can tell you it will involve some chemical engineering. In fact, I think in the last class somebody asked, saying that is this principles relevant to emerging areas, or it is old chemical engineering only, more or less, right. So, I have to tell you, even electronics fabrication shops involve a huge amount of chemical engineering principles. Professor Narajan was a shining example. He worked for IBM fabs. Up to that we are okay, but now what I am going to ask you to do that is to take one product, whatever, this, think and try to recap what could be a company, name of the company that either makes the product or designs the product or ideates and develops that concept of the product. 3. So, this is very important point. So, you have to think of a product which involves some chemical processing. You have to think of a company's name which actually is in the process of churning it out and selling it in the market, or makers. Then there are people who actually designers. Third is they go through the technology of what makes it finally happen. Trivial example is, take this pen, this ink, I said that there must be a formulator for that ink. It should flow under these conditions, but when it comes onto the paper it should stop flowing and it should hard. So, there is a bit of a technology involved in this, whatever polymer you use, pigment you use, exposure to air, diffusion, all that sort of thing. So, think of that. It is a very interesting way of reassuring ourselves that what we have been studying till now and what you are going to study the next 2 years is actually relevant for a lifetime. So, that is the point. Another example, I give this tea. I have given an example of the morning cup of tea that you take there. Here again you can take tea and then say a company that makes actually the tea, Tata Tetley, some of you Lipton probably, or Earl's Grey, whoever makes it, whatever. So, tea that finally is sold to you, some company is making it, that names are easy to catch. Then if you go back and say, well, who built the plant that makes the tea bags? Probably it is not very obvious to us, but there is a company and it is not necessarily the company that is selling the tea packet. That is the difference I want to make sure. Then go back and say, eventually if you visualize somebody is picking up all these tea leaves from there and putting it and then grading it and sizing them, grinding them, taking it to a place where the whole thing gets dried under controlled conditions. So, there is a dryer, fluid bed dryer probably, rotating drum dryer, whatever, drying, concentrator of drying, whole lot of things someone has worked it out over a period of time. So, that is the third angle. So, I give this because there are 3 broad types of companies. This is the central point to this class, saying that when you talk about chemical engineering companies, there are 3 broad type of companies, and these are, you can skip this, I will come to that later. These are the companies that make stuff, what I call as manufacturing companies. Secondly, the companies that build plants that makes these products, I call them as EPCM companies, you can see from here. Third is of course those creators who looked at nature and then devised innovative way of something getting transformed to something, raw material getting transformed to a usable finished product. That is the highest creativity part, that I call them for this purpose of this lecture technology development companies. So, 3 types of companies are manufacturing companies, pretty straightforward, all of us are easily relating with that. I want you to relate to something behind manufacturing, which is the engineers who build plants, what I call in this class as EPCM. EPCM stands for engineering, procurement, construction management. So, that is a company. Now, in each one of them there are management roles, and this is what I want you to think of, saying that a qualified good chemical engineer most probably will never be an engineer all his life. He will continue to have engineering skills, but very short period of time in your career you will transit into management roles, which means beyond a very narrow heat, mass balance, process control, chemical reactionary, thermodynamics, you will go something beyond to be able to see that the whole life of producing products and services that God forgot to make, and we have to make it and supply to customers who are willing to buy, involves manufacturing is one part of the activity. Therefore, there will be manufacturing companies and so on like that. It is rare for one company to do all these activities. In fact, I can't think of, from my years of experience, a single company which is actually involved in all the 3. The closest that came to my mind during my heydays of engineering is there is a company called ICI, Imperial Chemical Industries, for those British ICI. It is a fabulous company. Now it is, company is not existent. They came very closest to combining all the 3, because they actually developed technologies, they also built their own plants, and of course, they operated the plants in UK starting with that and worldwide. 3 types of activities, and therefore, 3 types of specialized companies. Rarely one company does all of them. This is a very important point here. Why is it important? Because each one of you has a very unique set of skills, ambition, desires, right, and that only you know it too well. Maybe you will disclose it to a close friend, but rarely we are what we are, right. So, you have to discover during the course and figure out which segment appeals to you most. There are a lot of criteria that you can use. Of course, the obvious criteria which I recommend you to do is that where the pay is very high, not a trivial matter, you should seriously take it into account. But that is not the only thing. I mean, if I say that, then you will laugh at me, right, you know that, but that is not the only thing. Therefore, you have to finally, after doing the basics, hygiene, checking up of what is what, you will also have to internally align it, does it make that appeal to you, which is why I said that we should know about these 3 types of companies. So, if you are considering working for a company, it is better to get to know what type of a company, where does it fall, and then it will give you some clue of what is that likely they are going to do in their lifetime, and does it also sort of match with what you want to do. Of course, you can start like I did. I started with a manufacturing company, my earlier career, then I switched to an EPCM company. Now, I am in IIT Madras trying to help faculty with the 3rd. So, it is possible, you are not stuck up for life, none of you are stuck up for life, but I followed a routine where I felt I had to gain some expertise, some knowledge, then I can move to the second one, so that I am respected. So, keep that in mind. You can start anywhere you want, it is a wide world, but if you start a place where it is intuitively appealing to you during your initial years, chances are you will do very well, and then you can every ever so years you can review and beyond like that. Okay? So, that is the point of this. Yeah, just a summary, the chemical engineering practice is basically making, designing, creating processes and plants that stuff is made. Now, in this, the small fine print is always very important to read the fine print. The major point is probably in the fine print. The things like constraints, external constraints are, which is not in your hands, is safety requirements are evolving. So, whatever you do has to be meeting the touchstone of safety at that point of time. The plans of 1960 today will not be agreed upon by anybody. So, today's standards are improved. So, safety, reliability is a very important point. What is the meaning of reliability is, simply put, if it runs without unexpected breakdown and failures, it is reliable. Windows used to be not so reliable in the past, suddenly it will by itself conk off. So, reliability is extremely important. Keep this point and later on remind me to explain to you why it is so. Obviously, if it is not of a right quality that meets the customer expectation and of a price that he is able to afford, there is no point. So, I will not get into that purposely, because in company the big change when you go from academia to that will be this cost, and we are going to spend few 4 or 5 lectures on cost, but now I am trying to underplay this cost. It is a bit of a contradiction, right? That is because cost follows technology, cost cannot lead technology. Therefore, you must first understand the basic principles of hardcore engineering and science. After that, a constraint will be imposed, then you can respond. I mentioned in the last class, I am concerned about the gradual hollowing out of talent, right? I think some of you would have. You join a company, let us say when you are 23, 25, after 20 years when you come for a reunion here, people are meeting each other. How many of them will still remember the basics? My batch was a good batch, decent guys, but I must admit probably 5%. It is not the 95% became poets or politicians, and therefore, in their day to day life you do not need to. These guys worked in companies and not in Google, all of them anyway. They worked in chemical companies, very well known chemical companies, and after 20 years you expect to be in some seniority, right? But with half apologetically, you know, I have forgotten all my Navier-Stokes equation. This is a pity. It is not a matter of joke. I really feel that, have you, okay, let me think of, put it this way. You go to a surgeon, and if you want to choose a surgeon for some personal situation, you are faced with somebody who is 25 years old, bright, smart, and you are faced with somebody else who is 45, 50 years old, slightly graying and all that. Intuitively, in the absence of any information other than look, who would you like to rely upon? We tend to, maybe it is a blunder, but that is because our experience, not one person's experience, cumulative experience of a large number of people has shown that in that profession, with time and age, you become better in able to handle variety of situations. Why is it not true for engineering? I used to wonder. I mean, we are not writing poetry every day, we are making stuff. So, you first make some stuff, does not work, after some time you learn why it did not work, then you become better, that remains here, does not go into Bird, Stewart and Lightfoot as a case, as an example, it remains here. Therefore, after 40 or 25 years when you are mid 40s, how can somebody say, I have forgotten? This is actually the in one line summary of why Indian industry is not very competitive. Anyway, getting back to the topic here is, what these guys are worried about is cost. The moment you open a discussion, people will say, okay, I would like to know what the cost is. That is why we do not land up anywhere. If you had followed basics of science and technology, you would be able to answer that question intelligently. Otherwise, any answer is a good answer, you can bullshit your way through. Yeah, over a period of 5 years, we are willing to bring down the cost by 40%. It is always, you notice, it is over a period of 3 years, I will bring it down by 40%. It is not that next week I will do this, because next week come too fast. So, keep this in mind. Real good chemical engineering is you should know your funda, but the constraints of externally imposed constraints like cost, safety, all that has to be addressed on a case to case basis. One small let us say semantics here. Very often if you notice, you go to any other class or people talk about industry, academia, blah blah blah. This industry comes into the picture. Academia, I think some of us we know, right? We are in the campus at least. This industry thing is a bit confusing. So, I do not want to use unless the context clearly requires for that word, because what is industry? It is a general grouping of a large number of similar entities. It is a big domain. For example, if you say chemical industry, what does it mean? I mean, guys have something to do with chemical. Similarly, auto, anything with moves, vehicles. So, that is helpful to statistical analysis, government reporting, whatever, but better to think of company, because company is an entity with a name, a product, a place and so on. You can link to a company, and in the industry there are companies and there are companies, and our life, if you are seeking for a job, you are not going to work for an industry anyway, you are going to work for a company who pays your salary, right. So, always make the difference of whenever I say word supposed to mean, even if I misuse industry, point out to me and say, can we get back to company please. So, because the examples have to be relevant to the companies, that is the point. Obviously, all of you know and you will know, all companies are not, even though they are in the same industry, they are can be extremely different with respect to culture, performance, way things are done, whatever. So, keep that in mind. We are going to talk about jobs in companies, not jobs in industries. Little example of the same point which I mentioned is that I talked about 3 kinds of industries, right, 3 types of industries, which is manufacturing, EPCM. Some examples are here. I given the specific names with the product for you to relate it better. Let us say the first one is in polyvinyl chloride, PVC stuff, you have seen PVC pipes, water pipes, this, that and all that. So, if I take PVC making as a industry, companies like Reliance, which is the largest of course, Finolex, and back here in Chennai close to our campus there is Chemplast Sanmar, who also contributed to our cricket ground here. So, these are the 3 companies which are actually manufacturing PVC, PVC granules, polymer. Some of them go to the next step of making it into a product like a pipe or a valve or whatever it is. So, that is a manufacturing company. Then somebody built those plants, right. You see these towers and reactors and heat exchangers and cooling towers are all spread all over the place. This companies that built the plants, which is run by Reliance, blah 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 blah, is, I have given some name. Ude is one very great company. I think those who are from the western region probably will hear about this more. It is a German origin. Friedrich Ude was the engineer from Germany. Now the company is named after him, and Technip is close to the campus. They have got a thing, and one of the Technip guys are going to come and address you anyway later on during the day. So, these 2 companies, they are called engineering services or EPCM, what I call. Their job is, if somebody is wanting to build a PVC manufacturing unit, they will say leave it to me, I will now design. You have to, all you have to tell is where you want to build the plant, what is the size of the plant you want to build, only 2 decisions. They will come back and tell you this is how the plant can be built, it is going to cost this much of money and I will build it for you, and I will build it and run it and show it to you and then hand over the plant to you. So, that is engineering services, very exciting. I am fond of engineering services. Third is Ude or Technip have not really spent R&D and tried to figure out taking vinyl chloride monomer and how does it react under what conditions into a polymer of a certain molecular weight, average molecular weight. They have not done that. That job went on to some of the names of the companies I have listed there. I have given the name of companies which are in like Ineos Vinyls is actually a PVC funda guys. The chlorine engineers in DNURA are people who have developed chlorine technology, and in PVC eventually somewhere if you go down to the basic raw materials ethylene and chlorine, you will get chlorine. So, chlorine. Asahi Kasei is a company that developed a fantastic technology for making caustic soda and chlorine. So, that sort of it. So, the idea was to say even in a product like PVC, which we call as a kind of a mature good old product, what is new about PVC? There are these 3 and there are opportunities for all the 3. Now, getting back to what is the jobs that we are thinking of. Obviously, what a company does within that industry of course depends on the company's own history, philosophy at that point of time, the way it is managed and so on, and the aspiring engineer who wants to work for the company, his interest, his ability internal what you have learnt and retained in you, and also at the level in which you are getting into that company. So, it depends on all the 3 obviously, right. So, the organizational level I will keep it excepting in passing for the next subsequent lectures, because that is a process in itself. So, let us keep that out, but the interest and ability part we will have to look at. What is that interest and ability is what we know, and you have to match the company which you are wanting to work for and figure out what is that they are wanting to have. That is where the link is coming. What is that they will be wanting from you depends on, are they a manufacturing company, EPCM, or technology development companies. Like I said, hardly a company which does all the 3. So, here is a time where it will come at some point of time for you to make up your mind. As a first option of course, everybody wants a backup, right. I wanted a backup always, I never decided on only one, suppose over here. So, I always look at a backup, everybody should look at a backup, have a first choice which is what you really want, then you can work out your strategy. Now, next 3 points are that manufacturing companies will require of you very strong basics of understanding, basics being what you have already been taught. To recap, thermodynamics obviously of course, chemical reaction engineering, transport processes, process control. I can't think of a 5th one. Not to say there is nothing more to chemical engineering this, but I am just telling you in context for a manufacturing company, if you happen to be very strong in these 4 matters, you can do a very good job. They would also appreciate your work. Of course, second is apart from technical skill is attention to detail. The devil and the angel both are in the details. This helicopter view, eventually given the right conditions, if you optimize, everything will work out in a suitable satisfactory manner, is very good when you are 50 years old and go to a management lecture. But entry level job, when you are saying heat transfer equipment, I am making choice on heat transfer coefficient, am I sure that what is the error in which I am making it? That is important. So, attention to detail is very important at the entry level. So, do not skip it. Of course, some amount of management ability is required. What do I mean management ability is, like I said, company jobs, no jobs are standalone. CEOs want to show that they are standalone, but no job is standalone. Therefore, your ability to network with others, which all of us have, I mean we are not dumbos here, we work in a society, right, but I am stating it for the sake of stating it. Your ability to not to get stuck with one particular definition of yourself. I am an engineer, therefore I will not look at it, that kind of a thing I mean. If you have broadly some flexibility and understanding, if you are strong in your basics, you can do a wonderful job, and that is what manufacturing companies are looking for. So, connection being, if you apply for a manufacturing company's job or keenly looking at it, after making up your mind that this is the skill they will look for and how good am I and do I like. Little EPCM, like I said, my favorite is, it requires stronger basics, much stronger than manufacturing companies, because in manufacturing companies it is simple logic, you can make it out. After all, how many products will you make? 10 products? Mostly they will be related to each other also, nobody will make completely unrelated products, nobody makes. So, more or less related products. EPCM companies can build a PVC plant, same EPC company can build a petrochemical refinery, same one can build a pharmaceutical plant, same one can build a paint shop. So, in terms of the variety of situations, EPCM companies have to deal with a large number of varieties, because their job is what? Build a plant, collect the money and then go to build the next plant. This guy is running it and making money for his lifetime, that is all right, but what about EPC company? I have to live. So, they are constantly they have to build new facilities, new created, therefore, the variety is more, and therefore, the number of domains that you have to deal with it is also will be very different, and therefore, the requirements from their employees, particularly entry level employees, that you are stronger in your fundas is more. Go back to the heat exchanger example I said. In a manufacturing company, you will know what is a heat exchanger, heat transfer coefficient. Heat transfer coefficient is a function of all that. But when it is running, it is not every day or every week. Acha, let us go through the heat transfer calculations. Things run, right, and actually a well run plant should run with little bit of modify, not every day you are like this. Whereas, designing a heat exchanger for let us say a reactor connected to a PVC manufacturing and designing a heat exchanger for connected to a reactor that makes ammonia, completely different ballgame. Therefore, you can now make out stronger basics are required of those who are wanting to make a career in EPCM companies. Rest is all. Okay. Communication to that extent is higher. Communication means your ability to explain your ideas to another guy and also pick up what he is talking about, both ways. It is not one way. Communication means I speak for 1 hour, that is not communication. I should be able to convey what I want to convey to you and make out you are actually understanding. Conversely, I must also make an effort to say what you are trying to tell me either by your speech or by your non speaking. That is communication, because you are going to deal with a large number of variety. So, unless you have this, you will struggle. So, that is the connect for EPCM companies. Third, technology innovators, I am searching for them, at least in India it is very hard. There are very few companies historically even today who are technology creators. Very exciting to think of as technology development, but not very exciting to think of as a prospect for a job, because the number of such entities are very less. Manufacturing companies, there are thousands, you can pick and choose more or less. EPCM companies are a few handful, India, globally both technology development companies. So, if you still want to pursue technology development, go ahead, but as an old man I have to warn you, you are engaging on a high risk path. You are, what is this guy who comes with all kinds of fancy strokes in 2020 cricket, Surya Kumar Yadav. If you are Surya Kumar Yadav, God bless you with this, but if you are more like me, look at the first two, okay, serious, and question me later on. If you think through that, I will be able to support it with data. Okay, before that, let me go back to the previous one. I forgot to mention this, my mistake. But things are not all that bad. Even if it is high risk, there is a joy, right, which is why SKY is what he is. What is required is that, let me finish that part, it requires the highest of the basics. You have to be top notch in your fundas, and this is where the beauty comes, and this is where the challenge and the interest comes. You should also have a very good understanding of business. It is not a contradiction in terms, and that is why I insist, do not think that engineers are not good business people. It is all a myth that is created by somebody with self interest. The real innovators of technology, if you read through the history, they have been top notch engineers and they had a good view of the world as it is happening and understood what will make business sense. Some of you are interested, read about steam engines. the name steam engines means everybody's name will come as either Watt or Stevenson, we will talk about, right. You read it again in some detailed reference book, another name will crop up. This guy actually also was an engineer, he made, by getting these two guys, talking to them, thinking about them, made it happen, because he could see the potential of a efficient steam engine in 500 different places. So, technology innovation, if you want to pursue as a career, I did not want to discourage, some of you are gifted surely. All I want you to know is that the risks involved in this, there are not too many in the world anyway, but what it requires is that you have to internally analyze, you have to have the top notch skills on both engineering, basic sciences, as well as a good understanding of the business area. Obviously, you can't be a master of all. So, therefore, you will be a very narrow specialist, but you will be real good. So, that is the meaning of this. Reassuring sentence, once again I repeat it, what you have been taught till now is absolutely sufficient for you for most jobs in manufacturing and EPCM. It may not be sufficient for you to look at EPC to technology development. This is the concluding one, I just am repeating it in terms of you just look at your hedging your risks. Okay, you long life, so we have to begin somewhere else and we have to go somewhere else, all this funda is good, but how do I go about means risk wise manufacturing company is least risky, because the requirements are reasonable, not bad, requirements are reasonable and opportunities are more, and anyway it is not a lifetime commitment, you are not kind of bonded labor forever, not at least in these days. Second one is EPCM, less number of opportunities, little bit more demanding and so on. So, you have to know, listening to all this, think through and chalk out your own career plan of what would you like to do. Okay. In the next class what I will do, this also next class is also on jobs, but I will now dwell into in each of this manufacturing, EPCM and technology development to small extent nature of job by names, engineer, this like that I will give typical job descriptions and tell you what happens and what is required. So, that is will be a little bit more detailed, no new principle, no new concept, it is more like acha tell me what happens in this situation, that kind of a checking out game. Now, career progression is then it evolves, because your interests change with time, probably opportunities outside also may change, and then you may then pick and choose and go through that. So, you do not plan your career day one, you have to have a broad strategy of starting where you are strong on, and then as we go along we have to flex ourselves and go through that. There is an assignment, this I will post it in Noodle, and you have to, key is 20th, it has to come through. So, I will take a minute in explaining what that assignment is. This assignment is you have to sit in a calm place and visualize you have passed out, you have joined some job, not necessarily in companies, not necessarily in chemical companies, you have to after all live, no, unless all of you have some godfather like Bill Gates or some fellow who is funding you. So, yeah, so think like that for the next 10 years when you pass out, 10 years starting from the time that you passed out, you finished your current responsibilities of graduation, and then you have reached somewhere, the 10-year journey you have gone through somewhere else. Then you have to write at the end of 10 years, assuming that you have gone through this, you are at 10th year, you have to write a resume. You are writing the resume looking for the next job, you understood, which will be probably very different from what your resume today will be. So, that is why I am asking you to first read this lesson once again, think, take your time, 20th is sufficient time. So, read this once again, think, discuss among yourselves if you want, and then visualize yourself what is happening to you for 10 years. At the end of 10th year, you are applying for a job, this is very key, beyond this I will be giving away the secret. So, I am just saying think and write that resume, short one. I am reading it, so do not make it 20 pages please. I know you are all very good. So, just one page, and again I know your names, you are all qualified. You have to concentrate on your work experience of that 10 years. That is all the portion I want, not contact mail address. Work experience, listing your accomplishment in each job. If you had more than one jobs in your visualization of 10 years. Again here it is not a sort of a no right answers for this. In fact, in the entire course assignments will have no right answers, because this is for you tailor made. So, what you write in after doing your homework is the right answer for you. Therefore, that is what you are trying. So, you can say in 10 years I am going to do only one job and I will write about that. I am looking for perfect. I have changed job once in a year, perfect, but you are writing for the job at the end of 10 years. So, that is the assignment. 20th, again I once again request you, I am very particular about the dates, because you can imagine if you write with a lot of effort, I am sure it takes a lot of effort, then it takes a lot of effort for me to go through 27 entries. So, I need time. So, please do that by time. That is all for today. See you tomorrow morning 10 o'clock.